Hi everybody, Aninga here. I wanted to show you an example of how we go through the processes of transcription and translation to try and clear up any misunderstandings or confusion. So in order to do that, we're going to have a single strand of DNA. So I have one side of my DNA ready for transcription, and then once we transcribe it into mRNA, we'll translate it into amino acids to make an amino acid chain. And while I'm doing that, I'm going to use both the codon chart here and the codon wheel so that you can see how both of those work in order to make uh, going from transcription to translation easier. Okay, so what I'm going to do is I'm going to look at my DNA strand here, and I'm going to transcribe it into messenger RNA. So the way that we do that is the same way that you would make a complementary DNA strand here. You would just take, your T, and you would put what it pairs with down here. So that's normally T pairs with A. Easy enough. In DNA, A pairs with T, but unfortunately T, which is thymine, it's not compatible with RNA. So instead it is replaced by something that is very similar to thymine, which is called uracil, which is going to be a U. So remember, in RNA, T's are all replaced by U's. Okay? So just remember that. As we keep on going, the C is replaced by G. That doesn't change, and G is replaced by C. Okay? Same thing all the way down the row. The only thing you have to remember is that A is then paired up with U for RNA only. Okay? So what I'm going to do is I'm going to transcribe my DNA, and to make it easier on myself, I'm just going to go through and just go through them one by one. So this one would be A, U, G, C, A, U, A, C, G, G, C, G, G, A, U, U, G, C, U, G, C, A, C, U, U, G, A. Okay, get rid of that space. And so what I've just done here is I have successfully transcribed my DNA here into messenger RNA. Okay, so what we want to do now, after we've transcribed it, is we want to take this and we want to look at it to be able to make amino acids. And to do that, we need to take our RNA chain and we need to make it into codons. Remember, codons are just taking 3 of our mRNAs and looking at them separately like this. Okay, so what I'm going to do is I'm going to make all of these look like this threesome of base pairs so that I can look at all my codons easier. Okay, so you'll see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9 codons. or 3 sets of 3. From here we can use either our codon chart or our codon wheel to find out what our amino acids are that we need to put down and in that order. So you will look and see that our first codon is AUG. Okay, so I'm going to use the chart here first to show you how that one works. So we take AUG and we look at our chart. It says on this side of the chart, first position. Don't worry about 5' end right now, but just the first position, which is the first one in our line, is A. So we go here, so we're in this row. Then our second one, we look at our next letter, which is U. Second position is up here, and that's U. So U, so A, U, so we're in this box here. And then we use this last line here to look at our last letter, which is G. So we're in here and here, so we're in this box, and you'll notice that we have the 4 here, G's right here, so it's our last one here we're going to be looking at, AUG. Notice it's listed right there. And so our first amino acid that we are going to have is methionine. Oh, I got caps lock on, sorry guys. That's our first one. Our amino acids sometimes will be represented by a 3-letter phrase. It doesn't say it here, but on our codon wheel, if we look for methionine, which is right here, it's MET. Sorry, MET. And that's our first codon, and that's how we found it, using the codon chart. Our second one, let's use the codon wheel for this one. I like the codon wheel a lot better. It's a lot easier for me personally to use than the codon chart, but it's all up to you which one you find is easier. So the next one, which is CAU, our first position is, so with our codon wheel we're going to start on the very inside and work our way out. So our first one is C, so we're going to start with the C in the middle, and then A is our second one. So in the second ring from C, you'll notice we have A, so we're in here, and then U is our next one, which is right there. So our next one is histidine. Sorry, histidine. Okay, and or HIS in this case. Okay. So we have our first 2 codons. And all you got to do in order to translate successfully is keep going down the line all the way down, just looking at each codon separately. So AUG was methionine, CAU was histidine. Let's do the next one, ACG. So let's go back to the codon wheel. A in the middle, the big one. Next one is C. Next one is here. So A, C, and then G. G is right here. So threonine is our next one. I'm just going to use THR. So that was this one. Let's try using the chart again for GCG. So first position is G. Second position is C. So we're in this box. And you'll notice no matter what third position letter is, it doesn't matter, it's going to be alanine. So sometimes when you're going through, like with the chart, if you know that everything in your box is, like for your third letter is going to be the same, it doesn't really matter what your third letter is, it's going to be that amino acid. So this one is alanine. So that was GCG. Next one is GAU. Let's try it with the chart again. G is our first letter. A is our second letter, so we're in this bottom box here. And then our last letter is U, which is the top one. So GAU, notice it's listed here, is asparic acid. Or aspartic acid, sorry. So that was GAU. UGC is next. Let's go and use the codon wheel for this one. U is our first letter, so we look at the middle and start with the big U. Then move to the second ring. G is our second, so we find that here. And then C is our final letter, so in our third ring, C, we'll see it's cysteine. Okay. Or cis. Okay. Then we're going to do UGC. So UGC again. So this is going to be cysteine again. And this can happen. Amino acids can repeat themselves. So if that happens, don't worry. That's normal. It happens all the time. Next one, ACU. I'm going to use over here. ACU. We got threonine again. So THR. And then we're going to look at our last one, UGA. So U, G, and A, which says stop. Okay, so when we have a stop codon, that actually isn't an amino acid. That's just something on the RNA that tells our ribosome or our ribosomal RNA that's doing our translation process to stop making the chain. So usually in an mRNA, you'll usually see this is what it starts with, because methionine is actually a start codon. And then we have stop codons. So this is what'll tell the chain to start, and it's the starter. And then we'll have a line of amino acids, and then it will stop at a stop codon. Okay? But that is how we do both transcription, which is going from DNA to mRNA, and then how we do translation, which is going from mRNA to an amino acid chain. And we used both the codon chart and codon wheel to find that out. If this is confusing, please let me know. Otherwise, I hope this helped in making it a little bit more understandable in what we had to do in order to read our codons to figure out our amino acid chains. Okay? So let me know if you have any questions, and I'd be happy to answer them. Otherwise, thanks for listening, everybody.